Now we'll have the second experiment, series and parallel resonance. The objective of the experiment is to find the variation of current with the frequency in the LCR circuit and to calculate the quality factor of the circuit. Now the aim of the experiment is to study the frequency of series and parallel LCR circuit and to determine the resonant frequency, self-inductance of the given inductor and the quality factor. Now here we have the signal generator, frequency generator. We have a voltmeter, we have an ammeter. This is the resistor, we have a capacitor and we have an inductor. So these are the following elements we have. So first let us look into the circuit connections in the series combination. So we have to start from the signal generator. So we have from the signal generator we have a wire and try to connect a wire to that. From there you try to connect to the positive of the milliammeter, one end of the milliammeter. So I'll try to connect to one end of the milliammeter. Then from the opposite end of the milliammeter you connect this to the inductor. From the inductor connected to the capacitor, and from the capacitor connected to the resistor, and from the resistor back to the signal generator on the opposite side. So you try to connect it like this. Meantime we have a voltmeter. The one end of the voltmeter is connected between the inductor and the milliammeter junction, so I can connect it together. And the other end of the voltmeter, it is connected to the resistor and signal generator junction. So I can connect it like this. This is the circuit connections in the series connection. Now, since everything is done, I can put on this. So here we have the frequency knob where I can keep the frequency at 2, and by pressing here 100, it will give you the frequency 100 into 2 becomes 200. And in this experiment, we are utilizing the sinusoidal wave. So we require to press this, and this is the amplitude of the signal. So by putting on, here we can set the frequency by pressing 100 button. So now the frequency become 2 into 100 become 200, and here is the amplitude where I can increase the amplitude from 0 to any value 5. So I can try to keep the value approximately 5. Now you try to measure the current as 1.1 for the frequency. Now as you increase the frequency, the current also increases. So for every increase in the frequency, current also increases, and you require to maintain the voltage as 5. Now these are exactly the readings for the frequency which you require to take now. So for your experiment, you try to take for the frequency 200 1.0, 400 2.0, 600 3.5, 640 3.8, 680 4.0. Likewise, the current goes on increases, and you can see at 800 920 79.9, but at 960 8.0 is the highest current, and later the current starts decreasing as the frequencies increase. Now these are the readings for the various frequencies from 200 to 2000 in the case of series connections. Now once these readings are done, you try to take a graph sheet, and in the graph sheet you try to take a scale along the x-axis as 200, 400, 600, means each centimeter is 200, and along the y-axis as a current, each 1 centimeter is 1 milliamps. Mark the points on the graph sheet and you will be getting the graph like this. First it increases and become maximum, and then it starts decreases. Now this is the maximum current, and try to draw a line corresponding to it. This is called I maximum. Now this is called as a peak current. If I divide this peak current by root 2, I maximum by root 2, it is what is called the RMS current. So corresponding to RMS current, you try to draw a line which cuts the graph at one point here and one more point here, and draw correspondingly the y-axis where it has got some frequency and one more frequency. This is called F1 and this is called F2. These are the lower as well as higher cutoff frequencies. And at the peak, you try to draw a line, and this is going to give you the resonant frequency. Now using these data, find out the resonant frequency from the graph and take down here. Then use the equation, that is the self-inductance. L is given by 1 by 4 pi square F naught square into C, where F naught is the resonant frequency and C is the capacitance of the capacitor given as 0.1 microfarad. Substitute to this and try to get what is the self-inductance of a coil. Now the same experiment can also be repeated for the parallel circuit. Now for the parallel circuit, you put off the circuit connections, you put off all the batteries, and here you connect the inductor and resistor in series, but the capacitor is in parallel. So what I do is that I will try to remove this capacitor and I will try to connect the capacitor in parallel with the inductor and resistor circuit. So here I can try to connect. And take a wire and try to connect between the inductor to the resistor, and this will give you the parallel combination of LCR circuit. Now you try to repeat this experiment for the various frequency, and here you can observe when I keep the voltage maximum, the current here is maximum 7.1, and as the frequency increases, you can observe there is a decrease in the current with the increase in the frequency, and the current decreases and becomes minimum. Now once again the current starts increases as the frequency is increased, and these are exactly the readings for you. Here we have the readings in the parallel combination for 200 frequency 7.1 and 4.9. As the frequency increases, it decreases to the smaller value, and then once again it decreases. Similar to the previous experiment, you try to draw a graph, take a proper scale along the y-axis as well as x-axis, and you try to mark the point and draw the graph. Find out the minimum current where the frequency corresponding to is a resonant frequency, and that resonant frequency you try to take it here. Now then you try to calculate what is the quality factor. By equation, quality factor is equal to F naught by beta, where beta is nothing but F2 minus F1 is the difference in the cutoff frequencies. So taking the F naught from the series circuit and F2 minus F1 from the series circuit, try to calculate what is the quality factor. Hence, try to write the result in the resonant frequency in the case of series LCR circuit and the parallel LCR circuit. Then the self-inductance of a coil in the series and the quality factor using the series graph. So try to calculate. Hence, the student is able to verify the variation of impedance of a LCR circuit with the frequency and assess the quality of the LCR circuit.